solve this equation. You have an equation on the board and you're asked to solve it. I don't think anybody's going to be surprised to hear, well, I don't think so. I don't think anybody's going to be surprised to hear that there is more than one solution. All right? Hopefully that's not a shock to anybody. This equation has more than one solution. Any suggestions as to how we'd go about solving this? Does anybody have any ideas, any thoughts, any times both sides by x plus 2, Noah says. And you're right. It's really cross multiplication. Then it will become a quadratic. Yes. Jeremy, you want to tell us something? Yeah, and it is the same as cross multiplication. And just for it to make it look more obvious that we are cross multiplying, I'm going to put this over 1 so that we can see that I'm taking the bottom of this side and multiplying it by the top of that side, the bottom of that side, multiply the top of that side. Now, one side is just a 1. So that means do we have to do that? Do we have to cross multiply? Noah is asking. Well, when we get on to other kinds of functions, you'll see why it really should be viewed as cross multiplication. Okay, Noah? Let's keep going. So I'm going to end up with x minus 3 times 1, if you like, being equal to minus 2x multiplied by x plus 2. Okay? Minus 2x, sorry, being multiplied by x plus 2. All right, okay. So that would mean that, Noah said it's going to be a quadratic, and he's right. So x minus 3, and I'm going to expand this. I'm going to take this times that and that times that. So it's going to be minus 2x squared minus 4x. All right, that's just distributing that minus 2x into the bracket. Like, I like to, when I start the class off, do a quick shout out and just make sure that everybody's back with me. Aksa, how about you? Are you back with us? Is Aksa there? Aksa is good. Okay. And how about Liz? Liz, are you there with us? Where's Liz at? Liz, are you there? Great. Emily, you was there? You're there as well? Are you following along? Perfect. Okay. All right, let's keep going. So what do I do now? I need to solve this equation. It is an equation. What do I do? Okay, let's see, Jeremy, yes. Okay, okay. So that means that you're going to be left with just a 0 on one side then, which is kind of nice because you're trying to solve a quadratic and you want to use a zero product law. So having everything equal to 0 is not a bad idea. So let's bring everything over to the left. So I'm going to have positive 2x squared, positive 4x, and then plus x minus 3 equals 0. Right? I just brought the minus 2x squared and the minus 4x onto the right as a plus, and now it's all equal to 0. Okay. So let's put our like terms together. So 2x squared plus 5x minus 3 equals 0. All right, so I've done that. Now what? Now what? You asked me to solve it, and now I've done this, and I still don't have an answer. So what am I supposed to do now? Come on, folks, jump in, Noah. Decomposition or magic X. Nice, Noah, nice. And Jeremy, you're probably going to tell us the same thing, yes? Okay. All right. So I love magic X. That's where I'm going to go. You don't have to do it. If you don't like it, don't use it. On the top, I'm going to put my minus 6. On the bottom, I'm going to put my 5. And I'm going to start asking, what two numbers will multiply to give me minus 6 and add to give me 5? Who can think about those numbers are? Add to give me 5, multiply to give me minus 6. 5 and 1, Noah. Oh, Noah, where is that coming from? You know that's not going to multiply to give you minus 6. You know that. Okay, so you're thinking, let me see what people are saying. Minus 1 and 6. Minus 1 and 6. So when I add them, yeah, I'm getting 5. When I multiply, I do get minus 6. Perfect. Perfect. Yeah, that's all right, Noah. Okay, and then what we do is for magic X, we divide both of these by the lead coefficient of 2. All right, there's 2 here. gets divided into both of these numbers. This first one cannot be simplified, so leave it as it is. This one can be simplified to 3 over 1. All right, 2 over 6 can be divided and it can come down to 3 over 1. So here we go. We're ready to go. One is going to be 2x minus 1, and the other one is going to be x plus 3 equals 0. Okay, so according to the zero product law, I'm multiplying two things and getting 0. It means that either both of these are 0, or at least one of them is 0. So 2x minus 1 is 0, or x plus 3 is 0. And in this case, x is equal to 1/2. In this case, x is equal to minus 3. So there are actually two answers for the question. Two answers, right? What seemed like just a regular equation, and when we're doing linear equations, we expect, and it's only one unknown, we normally expect there to be one answer. Turns out there's two. But do we trust it? Here's the thing that you should always do with rational functions. Always check to see whether your answers are legit. What do I mean by that? Sometimes when you're solving these rational functions, you get an answer which is a restricted answer, meaning it would be an answer which is a restriction on the original equation. So this equation, for instance, x cannot be equal to minus 2. So what if you got minus 2 as an answer? Could you accept it? No, you can't. Right? If it's a restriction, then you're going to have to say, as much as it seems like it comes out of this, it's what's called an extraneous solution. Extraneous means looks great on paper, but it ain't going to work. All right? Got to throw it out. But both of these answers are fine because the only restriction here is that x cannot be equal to the restriction. X cannot be equal to minus 2. Well, it turns out that neither of these answers is minus 2, so we're good. But I'm going to check it still, right? Even though the answer says that minus 3, answers say that minus 3 is one of them, I'm going to double check that. I'm going to put minus 3 in to the original function. So the original function was, I'll show you again, x minus 3 over x plus 2. So minus 3 over minus 3 plus 2 should be equal to minus 2 times minus 3. If we are right, that should work. Of course, both should work. Half should work as well. I'm only going to do the easier one, which is the minus 3. So minus 3 minus 3, this was x minus 3. So minus 3 minus 3, minus 3 plus 2 over minus 2 times minus 3. Where I saw x, I put that in. Is left side equal to right side? Well, let's find out. Minus 3 is minus 6. Minus 3 plus 2 is minus 1. The other side of that, I'm going to get minus 2 times minus 3 is positive 6. Well, the left side is positive 6. The right side is positive 6. Right side, left side. We're good. We're good. All right? You can try the half on your own time, see if that works as well. Okay. Now, remember Noah was asking, do we have to do that? Well, look at this example here. 2x plus 9 over x minus 9 is equal to x plus 2 over x minus 5. What is this now? The restivation rule only applies to the denominator, right? Restivation rule. I've never heard of the restivation rule. Can you help me out with that? Oh, restriction. Oh, I was wanting to some new thing we just came up with. The restriction only applies. Yes, we look at the denominator. That's all right. If you look at the denominators, it's only a restriction that you have to check, right? You have to see whether the restrictions that you had at the beginning could have made one of your answers what referred to as extraneous. Okay? All right. So, Noah, remember you asked me about do we have to cross multiply? Well, here's a perfect example of when cross multiplication is the only way out. All right? Oh, could I explain why a half isn't an answer again? Well, I didn't say it wasn't. I did not say that at all. It is an answer. Let me go back. Thanks for asking the question, Noah. Let's just show that it is. All right? Let's just show that it is. Yeah, no, yeah, definitely. In fact, you asked the question. Let's just test it out right now. All right? So I'm going to put, is it positive a half? A half minus 3 over a half plus 2 is equal to minus 2 times a half, right? So I'm saying that both answers are absolutely good, but let's just double check that. Let's just see if that's true. So minus 2 times a half, of course, is minus 1. Hope everybody agrees with me on that. A half minus 3, I'm going to hope that we can sort of cut to the chase on this a little bit here. A half minus 3 would be minus 2.5, right? And a half plus 2 is 2.5. So I have minus 2.5 over 2.5. I'm going to say that answer is minus 1 on the left, and of course it's minus 1 on the right. So we're good. So yeah. So in fact, both answers are acceptable. In this case, if one of these answers turned out to be x equals minus 2, that's when we have a problem. That's when we would say, no, we can't use a minus 2, it's extraneous. Looks good, but we can't take it. Okay? And thanks for the question. Okay, let's get back to this now. So now we're being asked to solve this equation. 2x plus 9 over x minus 9 is equal to x plus 2 over x minus 5. Okay. I'm saying, as I've said before, that we should be taking the bottom of this side times the top of that side, bottom of this side times the top of that side. That's what I'm saying. We're going to do exactly that. So we're going to take the x minus 5 and multiply it by the 2x plus 9 and set that equal to the x minus 9 multiplied by the x plus 2. And by the way, in this case, x cannot be equal to either 9 or 5. Let me state that restriction up front, because if any of those answers come up, we're going to toss them out. Can't use them. All right. So what do you think happens next? All right, let me get into the classroom here and sort of, Kayla, what do you think? What do we do now? What do you think we need to do now, Kayla? Kayla, are you there with us, by the way? Is perfect. What do you have any suggestions for us as to what we can do next? Because I'm trying to solve for x here. Trying to solve for x here. So looking for some ideas. Not sure? All right, let's go back and look at the one before this then. Remember when we had this this stage right here? Remember that, Kayla, from the last time? Does that look familiar? You're following along when we did that? Remember that step? Oh, we moved everything. Okay. But one thing we did first, okay, is we multiplied this out. Remember us doing that? And then set equals, okay. So what are you thinking needs to happen now? What are you thinking needs to happen next? So x minus 5 times 2x plus 9 is equal to x minus 9 times x plus 2. Any suggestions as to what I should be doing next? Multiply? Okay. So let's do exactly that. Thank you, by the way, Kayla. So we're going to multiply. I'm going to need some help with this. All right? I'm going to put some lines in here to help us to figure this out. You know how to file. Do the same thing over here. All right. Let me get some help on this now. Let me come over there and see maybe Keontae. Can you jump in and help me out with the first filing, please? Can you? Janai is right, yeah? Okay. So, Keontae, can you help me out with the first one? Give me the terms that you get when you multiply those two brackets. What's the first term, second term, and I'll go to somebody else for the third and the fourth. Keontae, your time. Jumping. 2x power of 2 plus 9x. Good. So, don't know why I'm on that color. Let me go back and put it back in black. So 2x squared and then plus 9x. Okay, thank you very much. Thank you, Keontae. Let's see if we can get some more help now from, let's see, Omar. Next two terms, please. Omar, are you with us? Are you there? Omar, perfect. Give me the next two terms, please. She did the x times the 2x and the x times the 9. Give me the next two terms. If you're not sure what we're doing, please let me know. I can give you some hints, but you need to let me know. Okay, so x squared plus 2x. Okay, you're in the second bracket though. We're not finished with the first two brackets yet. All right, she did the 2x squared plus 9x, and we're not finished with the first two brackets yet. So go back up the truck for me, please. All right, hit that rewind button. We're not finished with, let me point to it. We're not finished with this bracket yet. So go back and do that, please. We got the 2x squared plus the 9x. That Keonta gave us those two. Give us the rest. Minus 10x minus 45. Thank you. Okay, let's get to the other side now. Really, isn't it 2x cubed? No, no, because it's x times x, really. So it's not cubed. Okay, what they have is right. All right. Okay, so let's see now. Let's see. Travis, let's hear from you. Can you give us the first two terms of the other side? Travis, are you with us? Perfect. Can you give me the first two terms of the other side? So we finish with the left side. We'll tidy that up in a little while, but let's do the other side now. X squared, okay. Mm-hmm. So two terms, that's the first one, plus 2x. Good. Okay. And there are two more terms, and let's get Sharisa to help us out with that. Sharisa, are you with us? Perfect. Can you give me the next two terms, please? Two x. No, let's try again. We took the x times the x and the x times the 2, but what's the next two? Okay, so minus 9x, yeah. And what's that last term that you just gave us? Just give me that last term and then minus 18. Okay. Okay, so let's tidy up the left-hand side. 2x squared, 9x minus 10x is minus x, minus 45. And on the right-hand side, x squared minus 7x minus 18. Okay, so that's interesting, but that's just one step to the answer. So, Kristen, what am I supposed to do next? Kristen, you're with us, right? Perfect. Give me an idea of what you think the next step is. What am I supposed to do with what's on the board? 2x squared minus x minus 45 is equal to x squared minus 7x minus 18. How do I solve for x? Think back to what I think it was Jeremy did the last time we had a similar situation. And tell us what you think we need to do now. And I can go back to the other page if you need me to, but tell me if you need me to, or you think you know what the next step might be. Can we go back? We sure can. This is not meant to try to put anybody on the spot, but when we got to this point right here, you can see where I'm pointing, right? The x minus 3 is equal to, Jeremy said, why don't we take this stuff on the right side and put it on the left? So it's all equal to 0. So he said the minus 2x squared becomes a positive 2x squared. The minus first was a positive 4x. Then we had the x minus 3 that was there already. Now everything is equal to 0. Make sense, Kristen? Remember when we did that? Remember we did all of that stuff? Okay, so let's go forward now and have a look at this. We have this equal to that. Give me some ideas as to what you think we can do next. Any ideas as to how we can tackle this now? And I can go back again if you need me to, but I need to know if you have any ideas right now. So add the terms on the right to the ones on the left side and set it equal to 0. But you know when you add them, they change sign, right, Kristen? Right? So when you put the stuff from the left onto the right, you know that anything that was positive becomes negative and so on, right? You know that. Okay, so let me do that with you right now. So this is going to be 2x squared minus x minus 45. What am I going to put with that now? Equals 0. Tell me all the terms I'm going to put on the left side now. Give me all the terms that you're saying I should put on the left side. And you're right, but tell me how I should put them. I had a plus x squared, a minus 7x, and a minus 18. So what's the first term I should put on that left side? So minus x squared. Okay. Yeah, keep going. A plus 7x. And a plus 18. Good stuff. Thank you, Kristen. Okay, so this next part now means just putting my like terms together. That's all that is. Just looking for like terms and putting them together. So, how about if I ask Kale for some help with that? Kale, are you there? Where's Kale at? Not Kayla, Kale. Where's Kale? Kale, give me some like terms. Put everything together. What's the first term I'd get when I put my like terms together? I want you to take that left side that Kristen helped us to put together with the stuff from the right going over to the left and changing sign. Give me some, let's put some terms together now. Give me the terms that we left after I put them together on the left-hand side, please, Kale. Go, your time. Okay, so x squared. Keep going. Plus 6x minus 27 equals 0. Is everybody in agreement with what Kale just said? I mean, I know I wrote it down, but are you in all agreement with what Kale just said? Does that make sense? Was that properly done? Did we get all the right terms? Did we? Yes, we did. Okay, thank you, Rachel. All right. So what do we do now is the next question, right? That's fine, but what do we do with that? Jeremy, what do we do now? Magic X? We could use Magic X, but do we need to? Yeah, I'm asking you, Jeremy. What do we do? Mm-hmm, mm-hmm, mm-hmm. We're going to test that out there. Thank you, Jeremy. Let's test that out. So first of all, what he just said is right, and that's the fact that when you, excuse me, when you have a lead coefficient on a quadratic of 1, you don't really need the magic x. Magic x is only necessary when the lead coefficient is not 1, like a 3 or a 4 or some other number. But if it isn't, then you just simply set up two brackets and you factor right away. And the 9 and the minus 3 works because 9 minus 3 is 6. 9 times minus 3 is minus 27. There you go. Good stuff. So x plus 9 equals 0, and x minus 3 equals 0. So x is equal to minus 9, and x is equal to 3 are the two solutions that we can come up with. Now, let's go back and look at the restrictions that we had. We had x cannot be equal to 9 and cannot be equal to 5. Well, x is equal to minus 9, which is okay. If this had worked out to be 9, then we'd have a problem. Then we'd say, no, sorry, minus 9 looks good on paper, but it ain't going to work for this question. But minus 9 is fine and 3 is fine. So these are both acceptable answers. So good to go so far. Okay, let's try one more. I like that. We're going to cross multiply again and see what happens. Well, the first thing we're going to do is we're going to accept that x cannot be equal to 4 as an answer. Let's just accept that first. So both of these denominators, x equals 4, is a problem. So let's just get that out of the way. And then we'll go ahead and we will multiply. The same way we did that. I'm going to go through this one a little quicker than the last time. So x minus 1 times 2x minus 8 is equal to x minus 4 times x plus 5. Okay, so I'm going to multiply. I'm going to do the filing thing. So it's going to be 2x squared minus 8x minus 2x plus 8 is equal to x squared plus 5x minus 4x. 4x. Let me make that look a little better. Minus 4x minus 20. And then we're going to put everything over. Well, let's tidy this up first. 2x squared minus 10x plus 8 is equal to x squared plus x minus 20. And what we just saw, I think it was Kristen do a few minutes ago, brought everything over to the left-hand side. So that's going to, and again, I'm going to make this a little quicker. So that's going to be x squared. So minus 10 minus 1 is minus 11x. 8 plus 20 is plus 28 equals 0. Factoring. X, I know I'm going fairly quickly on this one. X minus 4, x minus 7. Right? So therefore, x equals 4, x equals 7. But this is a case where we knew x could not be equal to 4. So what we need to do is to say, as much as this looks good, this one gets a big red x. This is what we call an extraneous root. Because yes, when you do the algebra, 4 comes out, but it's no good. We can't take 7 though, because 7 was not a restriction in the first place. So x equals 4 is restricted. An answer of x equals 4 cannot be accepted as extraneous. All right, I'm going to move along now. I know I went through that one pretty quickly. I just want to give an example of when you get an answer which you cannot use. Okay? Now we're going to solve an inequality. Let me get rid of some of the stuff I have here. Actually, I'm going to leave that there. And let's see if I can maybe get rid of this. So what I'm trying to get rid of this as well. What I'm trying to show you from this, I'm graphing two things. I'm graphing so we're asking the question of this. So here's what we're asking. Let me move this up here. We're asking where this function 6 over x minus 4 is greater than x minus 3. So if you look at the purple line is my x minus 3 line, right? It's the straight line. And the 6 over x minus 4 is the rational function, right? The rational function which has a vertical asymptote at x equals 4 right there. And if I ask the question, where is the rational function greater than the linear function, which is to say, in fact, I'm going to get rid of the asymptote here. You don't really need the asymptote. Can you look at a diagram and make that determination? You actually can. I want you to look at this diagram and see if from the diagram you can tell where the part I'm circling, which is the 6 over x minus 4, which is this thing, right? That's the rational function. That's the red line, where that is bigger than the purple line. So to answer the question, you try to figure out where one is above the other. Where is this above the other? So let's see if you can follow me on this. This section of the graph right here, let me use a different color actually. This section of the graph right here is above the purple line. Can we agree on that? Can everybody agree on that? It's above it, right? One is, when you say above it, I mean it's higher up on the y-axis than the other. Karis is the only one who says yes. So that means that nobody else sees what I'm talking about there. Nobody else sees why that is the case. Is Karis the only one who accepts what I just said? Okay, so Noah says yes to that. You don't see where that, the squiggly part that I just put on there, right, is above the purple line. That doesn't make sense to everybody? No? Do I need to explain that a different way for everybody to see what I'm saying there? Let me check on the room because I've only seen 2 people so far. Joel, can you write the answer in interval? Oh yeah, we will eventually. We're gonna put it in interval, absolutely in interval notation. Does that make sense? What I just said? Right? I want to check in with you. Yes, that looks good. But there's another place where it's above it. Right? In fact, let me put back that vertical asymptote that I had before, because that might actually help us to sort of figure this out a little bit. I'm going to put the vertical asymptote back in. Let's put it in let's see, let's use green. Let's use green for that. That looks kind of green. All right, so here's my vertical asymptote right there at x equals 4. Now, where else, that looks good, okay. Where else is the red line above the purple line? So you know, Noah's asking put it into interval notation. We will put it in interval notation in a minute. All right. But I want to know where else can I color in and say that the red line is above the purple line? Does anybody see another place where that is, right, that I should be coloring in as well? Anybody else see another place? Jeremy, please go ahead. Mm-hmm. So you're thinking this part right around here as well. Does everybody accept that? What do other people think? Thank you, Jeremy. Does everybody accept that? Okay, Karis, and okay, so a few more people are coming in now. So it looks like the answer, based on the graph, or we have the picture, looks like the answer is as follows. Anywhere from minus infinity up to, it looks like about 1, right? And then it looks like you're going to union that with what Jeremy just said a while ago, anywhere from about 4 to what looks like about 6. And by the way, it says greater than or equal to. So I'm going to change this answer up a little bit. How should I change my answer up? Well, I'm actually putting anything on the 6 yet. I'm going to put on the 6 a square bracket. I'm going to put on the 1 a square bracket as well. Does there anybody see why I'm doing that? Because I said greater than or equal to. Or equal to means that they could be one and the same. They're in the same place where they cross each other. So at 4, no, they don't cross each other at 4 because at 4 there's nothing. At 4 there is no graph, right? That's why it's a round bracket there. There's a discontinuity at 4. But at 6 they're equal. At 1 they're equal. Anywhere from minus infinity up to 1 they're equal. Anywhere from 4 up to 6 they're greater than. Okay, so can everybody see from the picture what we are saying? Does the picture answer the question? I want to make sure now that everybody is on the same page with me on that. Does that all make sense? Right? All right, I just wanted to make sure. Just wanted to make sure. Okay, all right. So I'm going to continue now from that point onwards. So the graph is telling us an answer. Could we have gotten that by algebra? That's what we need to find out. Can the algebra give us the same answer? So we have an answer from the graph. I'm just going to circle it with red because we're going to come back to that and ask if the algebra is telling us the same thing. So if I'm going to do this algebraically, let me bring this question down. Right? How would you suggest we do this algebraically? Look at how we've been doing all the other questions so far. So Karis says cross multiply. Is everybody on the same page with Karis on that? Cross multiplication? What do other people think? Should I be cross multiplying? Come on, folks. I want to get some reaction from the room here. I don't want to have to call names out specifically. Does based on everything we've done, does cross multiplication sound like the way to do this? Remember all the stuff that we've done where it was equal. Just times both sides by x minus 4. You don't have to put the right side over 1. It's redundant. No, it just doesn't like this thing over 1 at all. All right, that's fine. That's fine. Okay, so Kayla is going to be on the same page with Karis, and Noah, in spite of his reservation about one part of it, putting over one part, it turns out that that may be problematic, but we're going to try it anyway, right? Based on what we've done so far, it seems seems like the way to go. Let's find out if it actually does work. So let's go. So we're going to cross multiply. And Noah, much as much I know you don't really like this, but I'm put it over one. I'm gonna go ahead and cross multiply. So I'm gonna say that 6 times 1 is just simply 6. And then I'm gonna have greater than or equal to x minus 3 multiplied by x minus 4. Okay, that makes sense, right? That's the cross multiplication that all of you told me I should do, and I've just done that. All right. So I'm going to go ahead now, and I'm going to multiply out the right side. So 6 is greater than or equal to x squared minus, I'm going to do it a little quicker now. Minus 3 and minus 4 gives you minus 7x, and then plus 12. All right. And I'm going to put that 6 over onto the right side. So I'm going to have 0 is greater than or equal to x squared minus 7x plus 6. Can we all agree on that, by the way? Does that whole thing make sense? All right. Just want to make sure that we're good. Okay. No, it's okay. Great. So I'm gonna change this up a little bit. I'm just putting this stuff from the right onto the left, so it looks a little bit more like what we're accustomed to. I'm gonna say x squared minus 7x plus 6. But instead of saying greater than, I'm going to say it's less than 0. It would make sense if I'm taking the stuff from the right and putting it on the left, I should also change the direction of the inequality. I'm hoping that makes sense to everybody. Because this was always saying that this side here is less than 0. That's what this is saying. That 0 is greater than this. So it means that this is less than 0. So that should hopefully make sense. That if we're going to switch sides like that, we have to switch the direction of the inequality. Okay. Now, how have I said we should solve? Because it's a polynomial now, a regular polynomial. What have I always said is a good way for you to solve an inequality for a polynomial? What did I always say we should do? Anybody remember? It's an inequality. An inequality, we solve it in many ways, like a regular equation, but not quite, because an inequality. That's a mistake a lot of you are making on the test, by the way, but I can't talk much more about that right now. So anyway, tell me, folks, how do I solve? What's the best way? What did I say is the best way to? We did this before with polynomials. Did I not say back then that drawing the picture would help us out? I guess nobody remembers that. Have you all forgotten the stuff we did in the first unit? Oh, jeez, that's not good. I'm going to draw this, but I need to do something with this before I can draw it. Right? What can I do with this before I can draw it? Right? How do I know what this looks like? Hello, out factor. Thank you, Arish. Thank you. So let's do that. And I'm assuming everybody understands that it's minus 1 and minus 6. So I'm going to go ahead and draw that. So that is at 1 and 6. And it looks something sort of like that. Okay, so I didn't quite get it. Okay, didn't quite get it, less than 0. I didn't quite hit the 1 and the 6 in the right spot. But can we now answer the question that I just asked? Where is this graph, where is this picture less than or equal to 0? Can you tell me where that is, please? Where is this thing less than or equal to 0? That's a picture. I just drew you a picture. Right? Between 1 and 6, I'm hearing. From 1 to 6. This is less than or equal, so I'm going to put square brackets on both sides. Let's go back and look at what we had up here. And for some reason, it's not giving us the same answer. For some reason, we have the 1 and we have the 6. All that's kind of in there, right? But it's not the same as what we thought it was going to be. So we have a problem. Houston, we have a problem. Does anybody know why we have a problem? Do we know why? What we were doing all along when we were just cross multiplying and it all seemed to work out really nicely isn't working for an inequality so much. Because the answer that we're getting now, the 1 and the 6 seems to come up with this, but it's not matching what we expected. So what's wrong? Does anybody have any idea where things kind of went off the rails? Right? Let's look back and see if we didn't make any mistakes inside here. We cross multiplied, right? We got that. We multiplied that out, brought that over, and we graphed it. And we're asking where this is less than 0. It's anywhere between 1 and 6. So that all fits. So what are we missing here? Right? It sounded like a good idea at the time, but it's not working out. Does anybody have any ideas as to why that is? Any thoughts on why we failed at our mission of answering? The graph should agree with our algebraic calculations, but it's not, right? So what happened? What went wrong? Well, let me tell you what went wrong. Okay, somebody has an idea. Jeremy, go ahead. Mm-hmm. Hmm. That's an interesting thought. That's an interesting thought. But here's something else which we talked about before, which we didn't take into consideration. You remember when we cross multiplied down here, x minus 4 times the x minus 3? Remember when we did that? Was that such a good idea? I'm going to say no. Does anybody know why that's not a good idea? It was fine for equations. So if you have to solve an equation, go nuts. Cross multiply all you want, no problem. You get your answers, you're good to go. But something is different when it's an inequality. No, let me get you to think about this. What is one of the things about solving an inequality that we learned? Isn't there a case where we have to change the direction of the inequality? Doesn't that come up sometimes? Does anybody remember us doing having to do that? Does anybody remember us doing that? Right? We have to change the direction of the inequality, and when was that? When do we change the direction of the inequality? If you divide it by a negative. Okay. So this x minus 4 that we multiplied by, could that be negative? Is it possible for x minus 4 to be negative? Because we just went ahead and cross multiplied and we just had a good time doing that. It seemed like a great thing to do. But are we multiplying by something or multiplying or dividing by something which can x minus 4 be negative? Is that possible at all? Right? That's the question I'm asking the class. Could this thing that I'm multiplying by be negative? Can it? Are there conditions under which this would be negative? This x minus 4. Are there values of x that would make this negative? Yes or no? Absolutely. So here's the problem. We would have to separate this and say, let's do this when what we're multiplying by is positive. And the only time this is positive, what condition would we have to set for this to be positive? X minus 4. What values of x would make this positive? When x is what? What values of x when x is greater than 4? There you go. So we can cross multiply if we knew that this x minus 4 was always positive. But x doesn't have to be greater than 4. X could be anything you like. What if x is less than 4? In which case, when we cross multiply, we should be also reversing the direction of the inequality. So here's how we're going to deal with this. I'm going to take this same question. Oh, sorry. I'm going to take this same question and we're going to do this the right way. So we're going to copy this onto a new page. So I'm not going to solve this yet. I'm going to create a new page. I'm going to paste this in. We're going to find another way to do this that will hopefully give us the answer that we had Oh, that's not, let me change the order of this a bit here. Let's move this up to here. I don't think I did that right, did I? No, I want this one. There's the one I want. That's the one I want up here. Okay. So we're going to tackle this a different way. We're going to do something which doesn't, we don't need to change the direction of the inequality if we do the following, right? I'm going to take this x minus 3 and bring it to the other side of the equation, right? Adding or subtracting as needs be. So I'm going to say that 6 over x minus 4 minus x plus 3 is greater than or equal to 0. Now, what I just did does not affect the direction of inequality whatsoever. It just doesn't, right? It still means inequality points in the direction that it's pointing right now. That does not change the direction of inequality. First of all, can we accept that? Just want to make sure that we all accept that. Does that make sense? Right? Okay. So now what do we have to do for us to be able to solve this inequality at this point? So it's 6 over x minus 4 minus x plus 3. Does anybody have a thought as to how we might be able to solve? Okay, let me help you out then. We have to find a common denominator and work through the process that way. Okay, and let's just do that. So I'm going to take this minus x plus 3, right, and put this over 1. Or let's put it, let's turn it the other way actually. Let's take 6 over x minus 4, and instead of saying minus x plus, let's say 3 minus x. It's not that it's going to make much of a difference by doing it that way, but I'm going to put that over 1 is greater than or equal to 0. I just like having the positive before the negative. So 3 minus x, same thing as x minus, is same as minus x plus 3. Well, I lost anybody so far. Stop me if that doesn't make sense. I'm just putting it over 1 because I want to find a common denominator, and I want us to go from there. All right? Harish, did that make sense? What I just did make sense? I just put the thing on the left, right? And then I just simply put it over 1 so I can find a common denominator. Harish, how about you? Does that step make sense? Okay, so let's keep going. What would be a good common denominator? Can anybody suggest a good common denominator that we could use? So x minus 4 times the 1 and then do the same thing on it. Okay, all right, so we'll do that. X minus 4. Okay, so let's see how this works now. What do I multiply, excuse me, what do I multiply x minus 4 by? That gives me x minus 4, it's 1, so it's just 1 times 6, plus, what do I multiply 1 by? That gives me x minus 4, it's going to be x minus 4, multiplied by 3 minus x, is still greater than or equal to 0. I want to make sure that everybody is with me on that so far, that everybody follows what I just did. All right, stop me if you're not sure. Let's keep going. 1 times 6 is just simply 6. And let's multiply this out. So plus, that would be 3x minus x squared minus 12 plus 4x all over x minus 4 greater than or equal to 0. Everybody with me so far still? All I did is what I just did, right? I just simply put all of that together, and now we're going to simplify it, all right? We're going to simplify it. So I have minus x squared. I have plus 7x. I have minus 6 all over x minus 4 greater than or equal to 0. Now, one of the things I always recommend if I have a negative on a quadratic is to factor it out. That's what I recommend. You don't have to go along with me on that, but that's my recommendation. I'm going to factor out that and leave me with this. greater than or equal to 0. Okay, so everybody with me so far? All right. And then I'm going to go ahead and factor the numerator of this. And that looks a lot like what we had when we were doing this before on the previous page. We did have on the previous page. Where is my previous page? Huh. I can't find my previous. All right, we'll just keep going. We'll just keep going. So we had x minus 1, x minus 6 over x minus 4 is greater than or equal to 0. All right, now here is what is the key step. Okay, there's some key steps involved. One of them is, of course, what we did before, which is to bring over the stuff that we had. The other key step in this is what I'm about to do right now. I can't cross multiply because we talked about that before. But now that I have a 0 on one side, what if, work with me here, what if I multiplied both sides of this equation by x minus 4 squared? So all of this being multiplied by x minus 4 squared. And on the other side, I'm going to do the same thing. X minus 4 squared. Why is it okay for me to, okay, everybody's asking why squared. Why is it okay for me to multiply by something that's squared on both sides? Well, we said that we can't cross multiply the way we were cross multiplying before because there's a risk that what we're multiplying by could be negative or could be positive. Now I'm multiplying by something that's always positive, right? X minus 4 squared is always, isn't that true already? That x minus 4 squared can never be negative? Isn't that true? Would you agree with me on that? So it's not going to violate the direction of the inequality at all if I do that. So it's okay for me to do that. But the good thing is that on this right side, I still have 0. Because anything times 0 is still 0. On the left side, guess what? Why did I choose x minus 4 squared? Because that is going to cancel out this thing down here with one of those on top. So what I'm left with is this on top. I'm left with the following. I still have the x minus 4. I still have the minus. Well, let me change that. I'm going to put the minus in the front because I don't want to confuse anybody here. Let me put the minus. There's a minus here. I'm going to put that minus in the front. Let me erase this as well. So I'm left with minus x minus 4, x minus 1, x minus 6. We're going to draw that. That's what we're going to draw. Again, we have a picture, and with the picture, we can come up with a really, really good answer. The key to this is multiplying both sides by the x minus 4 squared, which I did on the two sides. I multiply x minus 4 on this side, x minus 4 squared on this side. This side is still 0. This side cancels out one of the x minus 4s at the bottom. I don't have a denominator anymore. But now I have that x minus 4. There's still a negative here. That was there from before, and I factored that out. So I have this. So now we need to draw this. So it has 3 zeros at 4, sorry, at 1, at 4, and at 6. Hopefully we can all agree on that. There are those 3 zeros. Excuse me. 1, 4, and 6. This is a cubic function that has a negative lead coefficient. So I'm going to say that this looks something like this. In terms of its end behavior, it goes from quadrant 2 to quadrant 4. Now, I want to point something out to you. We're trying to answer the question of where this is greater than or equal to 0. So we have to be careful. We know that when we had a denominator of 4, this 4 here was a restriction. So instead of me going straight through, I'm going to put a little circle here to say that this really should not be a value in our answer. Okay? That really should not be a value in our answer. Now, I want to take you back to where our answers were before, if I can find where I had everything. Here we go. Okay, here's our answer. We said from minus infinity to 1, from 4 to 6. That's what we had before. Let's see what this graph is telling us now. Here's my picture. Where is this picture telling us that I am greater than 0 or equal to 0, by the way, greater than or equal to 0? What is the picture telling us? Anybody? Where is this great? Anywhere? In other words, where am I above the x-axis? From where to where am I above the x-axis? A lot of silence in the class. So it looks like I lost everybody. Looks like I left everybody behind. Can anybody see where this graph is above the x-axis? Where is it greater than or equal to 0? Can you see that from the picture? So between 4 and 6, and also, as Noah is pointing out, from minus infinity. You meant minus infinity, right, Noah? To 1, and then from 4 to 6. You agree with minus infinity? Yeah, you do. Okay. So here's my answer now. I'm going to say from minus infinity up to 1, put a round on that, put a square on this, union with, I cannot include 4 in my answer because 4 was an asymptote. I'm going to put a round on that. So from 4 to 6, square there. Now, go back and look again at what we said the answer was. I'm going to have to, I think it's forward actually. So minus infinity to, there we go, minus infinity to 1, 4 to 6, round here, square here, square here. It's exactly the same answer. So unfortunately, this approach of cross multiplication caused a problem. The 1 and the 6 comes up in the answer, but it's misleading. It's not right. Right? So my advice to you is, as tempting as it might seem, never, well, except in, I'll tell you the exception to that rule a little later on. You never cross multiply when you're doing an inequality and start trying to solve a rational function. Don't do it. Don't be tempted. I know it's going to look like this is the way to go, but don't. Okay? Don't. So the strategy is to find another way to do it. Add or subtract stuff to the two sides, multiply by something that's squared, that works, but never just trying to cross multiply straight away the way we did. Okay? All right. We're going to try, it says alternative method. I have my things all screwed up right now. Let me see if I can solve the inequality. Okay, let's try this one. And when we finish this one, I'll stop and give you a chance to get your homework done. Okay? So solve this inequality. Solve this inequality. Any ideas as to how you think I should start? Now, this is a quadratic over a quadratic. Okay, Jeremy, go ahead. Okay, okay. I like the second idea, which is to factor it. So we'll go ahead and do that right now. Right? We're going to factor it. So, well, let me go to the room and ask for some help on this. If we had to factor, Karis, can you help me out, please? Can you factor the top of this for us, please? And last one to factor the bottom. Karis, are you there with us? Okay. Okay. All right. So she's going to give me that top, and then we're going to get someone to give us the bottom. So stand by, folks. Everybody else, make sure you're ready to go, and I ask one of you for the factors of the bottom. So x squared minus 2x minus 15 over x squared minus 9x plus 14. All right, so Karis is about to give us the factors of the top, then I'll ask somebody else for the factors of the bottom. Actually, I'll tell you what I'm going to do. I'm going to ask Caleb to start working on the factors at the bottom in the meantime. Caleb, are you there with us? Where's Caleb? Good. Caleb, start working on the factors at the bottom for me, please. We're going to get back to Karis with the factors at the top. Then we'll talk about next steps after that. Okay, so Karis has the top as being x minus 5, x plus 3. And I'm going to agree with Karis on that one. And we'll give Caleb a chance to come up with the factors at the bottom. One of the things that I know Jeremy was hoping is that maybe we could maybe cancel some stuff out. That might make our job a little bit easier. We'll see if that's the case. So Caleb, over to you. Okay, we're just giving Caleb a chance to come up with the factors of the bottom. So please be patient, give him a chance to get that done. Okay, so x minus 7, x minus 2. Okay, so Jeremy, unfortunately, I don't really see anything that we can cancel out here. So I'm not so sure how we're going to solve this. Any idea? Disappointment. Can we cross multiply though? How about we multiply the two sides by x minus 7, x minus 2? That sounds like a great idea. What do you say? Right? Let's just cross that out, and then that would work, right? Would that work okay? What do you think, folks? Cross multiplication. Yay, let's do that. Yes? Yeah? Harry says yes, let's do that. No. No, it's right. No. Because x minus 7, x minus 2 could be negative. Depending on the values of x, it could be negative. Do what we did the last time. Absolutely. And then we graph it. That's exactly what I was thinking, Noah. I'm thinking, okay, I'm going to shift this thing over a bit here. And what can I multiply both sides of this by? What would be a good idea for us to multiply both sides of this by? Just the denominator? The denominator squared. So let's do that. Let's multiply it by x minus 7 squared and x minus 2 squared. And do the same thing on the other side. Multiply it by x minus 7 squared, x minus 2 squared. Now remember, this can never be negative. What we're multiplying cannot be negative. No way, no how, cannot happen, right? So what that means is that I'm going to just end up with a 0 on this side. But on the other side, one of these cancels out one of these, and one of these cancels out one of those. So what we're left with is this. X minus 7, x minus 2, x minus 5, and x plus 3. Okay? That's a quartic function. That's a quartic function with 4 zeros. So I can draw this. No, I should be careful because some of these zeros should be regarded as being like a little circle. The 7 and the 2. These two things here, the minus 7 and the minus 2. So be careful with this bracket here and be careful with that bracket there. I'm going to put a little circle when I'm crossing the x-axis with those. But here comes my graph. Here comes my graph. I have a plus 2. I have a plus 5. I have a plus 7. And I have a minus 3. Now, at the plus 2 and at the plus, I'm going to put some circles, some open circles there. because it says greater than or equal to. So we have to be careful. I'm going to put my graph in now. So here comes my graph. It has a lead coefficient, which is positive. My graph looks something like this. All right. Now, wherever I have the circle, I have to be careful because it means that that answer is not included. I have to restrict that answer out. Okay, so greater than or equal to 0. Here we go. Remember, greater than 0 means I'm above the x-axis. That's all it means. That's all it means. So let's get some answers now. Give me any part. Wait, sorry. Why do the 2 and the oh? They have. Thank you, Reddy. Thank you. The 2, not the 5. Oh, that's wrong. It's not the 5. That's wrong. Okay, so that's a good question to ask. Is this wrong? It's the 2 and the 7. So this is. Let me get rid of that. That's wrong. The answer to your question really is that I'm wrong. Okay, that's the answer to the question. So let me fix it. Let Mr. Camel fix that. That's wrong. Oh, let's use black actually. Come on, why is that not black? Thought I just pressed black. Okay, and then this needs to be 5. That's really weird, folks. The board is just doing what it wants to do right now. The circle should be here and here. Okay, so ready? I'm glad you brought that up because you corrected me. The 2 and the 7 is where we need the circles. Anyway, in the time that we have left, less than 5 minutes, can I get at least one of the answers to the question? Where is this greater than or equal to 0? What's the first part of it? Okay, go, Jeremy, go. Okay, okay, whoa, stop. Round, square, what kind of brackets are we looking at here? Good. Thank you, Jeremy. All right, somebody else give me another part of the answer. Where else is this thing greater than 0? Reese says from 2 to 5. And 2 is not included, but the 5 is. Anywhere else from 7 to infinity. Round or square, Ava? Let's get this. Let's make sure we get this right. Round or square? Round on both sides? Yes. Oh, and then square, you're saying. So round and then square, is that what we're saying? So round on one end and then square on the other. Everybody agree with that? From the 7 onward? Okay, Noah says no. All around carries 7. Okay, round on both. All right, I'm going to have to agree with the last few people. So you're on the right track when you said that it was 7 to infinity, but it has to be round on both because 7 is not included and infinity never gets a square bracket. Okay, and I cannot figure out why my pen is now showing red, because as far as I'm concerned, the thing that is highlighted is blue. Sorry, is black, but we're not going to, the colors don't really matter that much, so not that big a deal. All right. Okay, thank you, Eva. Thank you for your answer, by the way. So that little technique is kind of useful when you're answering questions like this, right? You factor it first, yeah. And if there's an opportunity for you to cancel something out, absolutely go for it. But there isn't, then let's multiply the two sides by the square of the denominator. If one side is already 0, which means that multiplying the other side by the squares is not going to affect it. It's still going to be 0. And it's going to be positive because you're multiplying by something which is squared. Then you can turn it into a polynomial. Just pay attention to the denominators. By the way, you only pay attention to these denominators when it's greater than or equal to or less than or equal to. This had just been greater than or just had been less than. I wouldn't really care because all the answers are going to have round brackets anyway. Make a little note of that somewhere. It would all be round. This was greater than, but not equal to. Okay? All right, I am going to leave it on that note.